welcome to another episode of Adventures in DevOps. That's the title of this podcast that we settled on. I'm one of your hosts, Nell Shamrel-Harrington. I'm a principal engineer at Chef, coming to you from Seattle, and I am, of course, joined by my wonderful co-host. Lee, how are you doing today? You want to introduce yourself?
Yes, another day in paradise. I am Lee Waylin. I'm also based out of Seattle, and I run the greatest DevOps consultancy that nobody's ever heard of, Fuzzy Logic Systems.
All right.
And I'm Scott Nixon. I run Cloud Mechanics, which is basically an open source cloud consulting DevOps business, and I am located in Central Oregon.
Awesome. Well, it's fantastic to be here with you two today. Today's topic we decided on before the show would be containers. Talking a little bit about what is a container, is it different from configuration management? How is it different from configuration management? How do the two go together? What should you do with a container and what should you not do with a container? So containers are definitely one of the hottest buzzwords, I would say, in the DevOps world, at least over the past few years. I'll have to find the link to put in the show notes, but there's a DevOps bingo card and I think at least like 3 of them are related to containers. But let's start off with what are they? Behind the hype, behind the buzz. Lee, how would you define a container?
Oh, that's this is good because I was just having this conversation the other day. The way I describe it, which is going to be so incorrect that the container mavens listening to this are going to cringe with the gross oversimplification. But for helping get it across to more old school sysadmins, I just say that a container is basically a very fancy cheroot. It lets you isolate a process or processes in a way that hopefully is very hard to jailbreak out of, and it gives you finer grained control over the resources that container can use. You can give it an IP address. You can give it ephemeral or permanent storage, and all sorts of fun stuff.
Awesome. Scott, how about you?
I think I would start off by trying to describe it as like a disposable, immutable, place for you to run an operating system and applications within, but it's meant to be used in such a way that it has a very short life, that you're probably updating it very often. I don't remember where it was from, but there was, I probably even mentioned this in the last podcast, but there was some statistic that somebody had put out there that the average container life is like a half a day or something like that. And it's obviously great in environments where you have a lot of horizontal scaling or microservices and stuff like that, because it just allows you to easily move things around, scale up new things, and kind of run anything in it now that you can do everything from Linux and Unix and Windows in it. So that's how I would describe it.
Awesome. I think how I would describe it is whenever I'm teaching about infrastructure to newer developers or people who've been in the development world for a while but are just getting exposed to the ops world, is I say, all right, we started off when I worked at the University of Washington in 2009, we ran every application on a separate physical server. It would have the operating system, would have all the software needed to run that application, et cetera. Now, where we moved a few years ago as cloud computing became very prominent was the idea of a virtual machine. So this is a virtualized server on a physical server, but you can have more than one on that physical server. However, in that virtual server, you still put an entire operating system. You still install everything you need to run it. It's a lot like a physical server. It just happens to be virtual. Now, containers are where things get a little different. The way I define a container is meant to run only one part of your application with just enough operating system components to make that piece of the application work and absolutely nothing more. And that's what makes them so fast. That's what makes them so flexible, is because they're just what you need to run a specific part of the application and nothing more than that. And that gives you a lot of freedom and a lot of flexibility to scale out, to isolate each of your services if you're doing a microservice architecture, and more. But going back to what you said, Lee, something I often remind people people is containers, they aren't really new. They feel new, or at least new in the past decade, but it goes back to the original Chroot containers on Linux systems. The reason I think there's such a hot topic today is Docker largely, though there's other companies involved in it too, made them easy to use and made them really easy to use with cloud computing. I mean, well, there's still hard parts about them, but they're a lot easier to use than they used to, and that's really brought them mainstream. Right.
I mean, if you want to get super nerdy and neckbeardy about it, so Solaris had zones, FreeBSD, or maybe it was even early, just regular BSD had the concept of jails and all sorts of fun stuff. I remember a recent Seattle Tech Talk. Oh goodness, it's 2019. A not so recent Seattle Tech Talk. A guy named Benno had this great monologue going on about how, look, when you're dealing with a FreeBSD system, jails are a first-class object. Like there's kernel calls that say, okay, here's what a jail is. Boom, go. Whereas in Linux, containers are kind of a bastardized hybrid of C groups, network namespaces, and one or two other things. And Docker, like the Docker command, let's not get into the whole Docker replacements and all that jazz. That's a friendly wrapper around using kernel C groups and network namespaces and all that junk.
Yeah. So one of the things I was going to add to kind of my definition a little bit was about how, and both you did a fantastic job describing so many different, like we all kind of came at it from very different ways, and I love that. But one of the things I thought about it is about how containers are often, you're not storing data in these things. You have databases running elsewhere, and you have EFS, you have block storage, you have data other places, and so these containers are literally just running the applications, and that was something that like I kind of left out of my definition that I think is really important to like how kind of we're modern using it is, and it made me think when Nell was talking about VMs, it's kind of funny because like when you have a VM running, right, it's still like connected to this read-writable file that's basically like a virtual hard drive, right? And but in the containers world, that kind of completely kind of goes away. Really, like you can obviously mount storage to containers, but it's typically the way you're expected to connect. Typically you would want to connect containers is you want to do it through some kind of a service layer, whether it's an API or instead of, hey, I'm connecting to some physical file on my file system and that kind of thing. So it's just something that I think I don't know, it's stuff that just really stands out to me. So
any thoughts on why you would want to do that? Do it through an API versus one of the more traditional methods?
The reality is that, like we had said, like you're essentially putting services behind, you're putting these containers behind, say, some type of load balancer that are kind of able to scale behind that kind of endpoint, and so that all these other devices are talking to that endpoint instead of talking to, say, this IP, this specific machine.
It highlights how containers are temporary.
Mm-hmm.
Like I wouldn't want to put if I had a elastic IP, I guess I could theoretically bind the load balancer to an IP, but I wouldn't want to do that necessarily.
Mm-hmm. Yeah.
Something I know we'll definitely cover when we talk about containers do's and don'ts is that idea of data, not keeping the data in the container, but keeping the data in something that can be mounted to the container. That's a common mistake. I see a lot of organizations that are just starting out on their container journey making.
I like literally whenever I was first messing around with Docker, I literally was trying to like figure out how to like spin up Postgres and then restore a database and then have it like how do I do this whole local file thing? And it just like, I just wasn't mentally there for whatever reason at the time. And then somebody was like, oh yeah, you have to like mount things. And I was like, oh, okay. So, and, and of course doing it in the cloud, you're typically is better if you can to not have to run your own database and use something like RDS or Aurora or whatever. So
awesome. Well, we talked a little bit about what containers are. What would you say to someone who said, all right, let's say I have a LAMP application that's Linux, Apache, MySQL, and PHP. And someone says, I want to take this application and I want to run it in containers. Where would you tell them to start?
I wouldn't even go that far that fast. I'd ask them why they think that they want containers.
Good point.
Mm-hmm.
Do we want to just assume for the sake of conversation that they have a really good why reason and go from there?
Why? Let's pause here and let's talk about when is a good situation to use containers in.
That sounds great.
I mean, to me, it's when you're trying to scale individual parts of your application. So, Amazon, right? They don't want the search taking down the checkout process. And so that's why the loosely coupled thing is a big part of these really large sites, is that you don't want to interrupt, you don't want to take down the whole application or significant parts of your application because one thing isn't working. And so when you push things into containers and you separate the functionality, then you worry about scaling those individually. What's also happened is, right, people are reorganizing their development teams. Like you have the growth hackers and everything, where they're focusing on just onboarding, or they're focusing just on, maybe some marketing, landing pages and stuff like that. And so everybody is especially these bigger companies, they're focused at such a very specific level, and everybody's given very specific metrics at that level. And it kind of gives them, when all the onboarding code sits in its own set of containers or own set of services, right? It gives them the opportunity to, completely manage that whole thing. Sorry, I feel like I'm rambling. I kind of lost my
It's all right. Lee, what do you think?
Well, I personally think of containers as a very highly specific optimization for an infrastructure. In my practice, I talk with a lot of startups and a lot of mature businesses. And I would say that the containerization thing is definitely much further along the maturity spectrum before I reach for it. The reasons are because generally in a startup to early stage profitable business, there's a premium on being able to troubleshoot quickly. They want things simple so that they can iterate fast. But Scott had some good points about being able to break apart the different parts of your infrastructure, so that if the search VM goes down, it doesn't take down the web VM, and so on and so forth. Containers help with that, but from a simplicity perspective, especially if a company is in Amazon or Google Cloud, having an internal load balancer splay out to a handful of systems gets you that exact same thing, but you don't necessarily have to go the full Kubernetes on it. And then that simplicity, especially when the absolutely staggering amounts of traffic and wild traffic swings aren't there in an infrastructure. So I tend to say of containers as a almost a very late stage recommendation, as opposed to the big thing is going around and recommending, oh yeah, go straight to containers. Just don't stop and go. Don't worry about any of the other aspects around it. Straight to containers, and then you are a fully Gartner compliant infrastructure.
Completely agree.
I agree on that too. I find the time I like to bring containers into an application is when the application is at a point where I want to split parts of it apart and have them just connect to each other over APIs. And it's going back to the same reason Scott mentioned and Lee, you reiterated, is if I have an application where if one part of it goes down, I want other parts of it to still be up. Bringing it into containers, bringing it into separate services, that's a good point to bring it into that. Now, as for the full Kubernetes, I usually think you should be dealing with hundreds, if not thousands, of containers if you're going to bring in Kubernetes. in Kubernetes for our listeners is an orchestrator that helps orchestrate Kubernetes, orchestrates resources like stores where you keep stateful data, load balancers, and other things. And it's really cool. It's really useful. Everyone says they want to use it, but it adds a lot of complexity to your environment. Now, there are times when that complexity is absolutely worth it, particularly if you're at Google scale. That's why Google developed Kubernetes. But I hesitate to recommend someone go straight to containers and Kubernetes when they're creating their first storefront website, let's say.
Yeah. All of my agreements. Kubernetes is a carrier grade solution, and unless you have carrier grade problems, you can certainly shoehorn it in there and spend a ton of engineering and operations time, making it work and making it do the dance. But I have yet to talk to a business who didn't really need Kubernetes say, oh yeah, that 8 months or that 16 months that we spent, making that work and all the upgrade cycles we had to do in between, that was totally worth it. The opposite tends to happen where it's like, if we could just rip this thing out and go back to something a little bit more boring, that's, we totally would. But because reasons, where it tends to be at the intersection of, ego, art, opinion, and commerce, we can't do that.
Yeah. And I think early, if you have a small site, you don't really need a lot of containers. If you then are not going to go and use some kind of service that's going to manage the management or already, EKS, ECS, Google's container services. If you don't have somebody that's managing those servers, then you have to then spin up extra servers to manage your set of services, and it just gets out of control, and you just don't. It's complexity you don't need.
I'm curious. You said small site. What is a what is a small site to you?
I think it really millions of visitors. Definitely less than 1 million visitors. I think a lot of it has to do with load, right? If it's SaaS app, it's going to be significantly more intensive depending on what you're doing. But I've spent a lot of time in contents in the content site world. And so content sites are, you can serve tens of millions of page views off of very little compute. Because a lot of it is it's purely like HTML, and then everything's out on, CDNs and stuff like that. So.
All right. Well, bringing it back a little bit, let's talk about, let's say someone has a LAMP, Linux, Apache, MySQL, PHP application. Let's say for the sake of this example, they have good reasons for running it in containers. Where would you recommend that they start?
I would say containerize the web server and the application server. And this is presuming that they're using a pattern where the PHP bits are not running in under the Apache mod PHP thing. I'm thinking if they're using an application server like PHP FPM and they're just using Apache to proxy back. And honestly, at that point, I'd recommend they use Nginx or HA proxy instead of Apache. But that's a whole other. There is no cool acronym for that.
We don't need to shave that yak today.
Exactly.
I kind of drifted off. And so Nell, if you want to offer an opinion, I don't have anything at the moment.
Oh, sure. I agree with you, Lee. I would the one thing I tell people is if you have an existing application and you want to containerize it, start with one first.
Yes.
Don't try to do the whole thing at once. That's going to be immensely painful. And start with one. So I would also agree, take the Apache server or whatever web server is recommended and start with that. That's going to give you a good sense of how containers work, creating, let's say you're using Docker, creating a Docker file, creating a container image, and then spinning up containers from that container image. That's where I'd recommend as someone start from.
Right. And that's an even better choice because the web server end isn't going to have a ton of stateful data writing to it.
Exactly.
It's a couple of network connections and it's a log stream. I would recommend not containerizing your database, although I'm sure, we should probably get a forum or some other discussion thing for the podcast. So whenever I get something wrong, people can come on and yell at me directly. But in general, I would recommend not running your database in a container just because of all of the giant, hairy ball of stuff around trying to manage the stateful data that a database by necessity runs.
Yeah, and databases are not something that can run stateless like a web front end and stuff can do, right? And databases are not something you just, we'll just spin up a bunch of SQL things. That's just not how it works. You got to put SQL servers into clusters and,
right.
Log ship and whatever, so.
Yeah, before we get the actuallys on Twitter, something a pushback I've heard from that occasionally, and then I'll explain it, is, well, you can put the database engine in the container and then just mount the storage data to the container. And yes, you can absolutely do that. But when people say database, in general, they don't usually mean the engine. They mean the stateful data that engine serves up. So yeah, if it's something you want to stick around from deploy to deploy, it should not be in the container itself.
Mm-hmm. Yeah.
Yeah. So, the way you make a container, let's just talk about that briefly. I mean, if it's a Docker container, what I do is I decide what part of my application I want to put in the container. I don't recommend putting the whole application in the container. And then I create a Docker container image. You can create a Docker file. You can create that file directly, or you can use something like Habitat to export your application to a Docker file. Habitat is, I'll put that in the show notes too, is a product from Chef. I'm on the core team of it that allows you to easily export your applications to whatever format you want to run them on. So with that aside, and then what I would do is I would upload that Docker container image to a registry such as Docker Hub or ACS, Azure Container Services, whatever the AWS Container Services. It's alphabet soup in acronyms for cloud services. And then I would have my container running.
Yeah. Right. I mean, I think it's important to note, depending on how far we want to move down to, tactical from strategic, your Docker file it's just a flat text file. Mm-hmm. At the very top, you've got a from directive, which is where you pull in your base image name, or if you wanted to go, full hashtag yellow ops, you can do from scratch. And then I don't actually know quite how that works, but it pulls a kernel space from somewhere. Mm-hmm. And then you start adding other directives like, hey, pull in my Git repository from here. Run this command. Make sure that you save this data. Make sure that your standard out and standard air are piped to here. And if readers at home want to follow along without having to rewind and play back my babbling, just do a search for Dockerfile reference or intro to Dockerfile, and the web is just lousy with basic intro level Docker files. And then you build your Docker file, you do Docker build, presuming you have a running Docker daemon and development environment locally, it does the thing, and then you have a containerized process that you probably have no idea how to access. And we can leave that as an exercise to the reader on how to figure out how to get to it.
Yeah, some of the stuff I was thinking about was, and this is my standard when I start breaking things apart, especially content sites, is, doing caching. You set up memcache and, or using job queues for, push that stuff into that first, there's just, it's kind of an easy win. I mean, and obviously if you're doing in cloud services, a lot of that stuff's just an API. And so maybe you don't have to do Docker services. You can just use the built-in functionality that in whatever cloud you're in. But those are the things I often go for first.
Awesome. Well, we kind of started covering it, but I was wondering, maybe rather than container do's and don'ts, we can talk about good container patterns and I don't know what apparently I'm from Staten Island because I just said container, but a container anti-patterns. So as for good patterns with containers, As with any pattern, this one has a caveat, but I'd say running applications as microservices is really useful when you get to a certain scale, which is often a very good thing to use with containers, to take all the stateful microservices that you have and gain that flexibility and ephemeral nature of containers. The caveat is, and I have personal experience with this, if you find you have a microservices architecture and you're having to change 3 or 4 services every time you change one, you're missing out on all the benefits of microservices, because it doesn't have that independence, that API contract between them if it has to change constantly like that. So what are some good container patterns that you two can think of?
Well, the big one that I run into, even after having been doing this for a while, is creating large images is going to come back to bite you in the backside sooner than you would think. Even today, I still find that, I've accidentally pushed my debug container into the staging environment, and now all of my staging metrics are starting to return very low watermarks. So make sure that if you do have a development container that has all your tools and stuff in it, make sure that you before pushing it out, you pare that down to the bare minimum just to run your application. You aren't going to need, for example, JQ or Vim or any of the 6 dozen other useful tools that are great for debugging, but necessarily don't need to be they don't need to be in production or staging. Yeah.
And I mean, for me, I think a lot of this goes around, if you can avoid building a custom image, don't build a custom image.
Right.
And if you build a custom image, make sure you take the time to automate the image building with, oh gosh, I can't think of the tool from HashiCorp.
Docker. Oh, there you go.
Yeah, that's what I meant. So those would be my things that I would definitely be thinking about.
Oh yeah, Packer is a great tool.
It is.
Oh, and you can also update AMIs if you're on AWS. You can use the systems manager to literally patch AMIs, and it'll all those fun things, security patches, that kind of stuff. So
something I've also found a really useful pattern for containers is using them for development environments. Now, again, there's caveats to this, but if everyone who's contributing to your project or working on your project has a workstation that's capable of running Docker, some of the older Macs are not able to, but if they're able to use a cloud instance or something like that, it's a good way to almost instantly, as soon as they install Docker and get those containers up, give them that kind of the same kind of development environment everyone else has.
So important.
Very much so.
Mm-hmm. Yeah, totally. I mean, that's definitely where I started, the first, couple of hours of me doing anything with containers was all on development, of course. So figuring it out. Right. So, and being able to, you can certainly, deploy a full test environment or some smaller version of an actual test environment into, say, a cloud provider. But if you wanted to do things locally, to set up 5 different services on your local machine, really the only easy way to do stuff like that is with Docker,
Yeah, I remember in my Ruby on Rails days, I'd be developing multiple Ruby on Rails apps on the same workstation, and the gem conflicts. Oh my God. Yes, there are ways around it, but still sometimes having the differing dependencies would really conflict on my system. So
is that before RVM or whatever?
No, it was when RVM was around, but still sometimes things would just and yes, you can use gem sets and such with it, but still things would sometimes just start clashing.
Yeah. I'm not a Ruby person at all, but I know, Python, we have pip and all that stuff.
Right. Virtual env.
Virtual env and
all fun stuff.
Yeah. So, well, cool.
Awesome. Go ahead, Lee.
From a slightly more, purple belt level containers, using caching properly can make your builds much more efficient. What I mentioned earlier, for people who aren't super container ninjas, you've got a variety of Docker commands you can cram into your Docker file. Commands like add and volumes, that will invalidate your cache very, very early on. So you want to try to batch those together, probably towards the end, if at all possible. And run command, which is basically telling your Docker file when it's building, hey, run this command. Those the output of those commands are cached, and they'll remain cached in that layered file system until they change, at which point, from that point forward, your Docker file is built anew. So judicious, knowing how the caching bits work can save you, a few hours of debugging. Hey, why is this build so slow?
Yeah, we'll link to it in the show notes, but Docker has a document that basically says best practices for writing Docker files, which will directly address a lot of the things you're saying, Lee.
Excellent.
Something else I want to mention too, if you're running containers locally, if you're not stopping them, whenever after you use them, they can use up all of your system resources pretty quickly. So what I do is I have a command. I just pulled up my bash RC file so I could remember this. The alias is nuke_docker, and that runs docker stop, docker remove, docker system prune, docker volume, prune the Docker volumes, and then remove the Docker volumes. So it's a bunch of things, but it keeps my system running pretty nicely.
That's a good thing to stick on your build server or build slaves, because if you're doing Docker builds there, all those containers get cached, and it can be non-obvious trying to figure out, like, okay, which of these container remnants do I actually need?
Awesome. Well, we've talked about some of the good patterns for containers. We've kind of addressed that we can address it more, the anti-pattern of keeping stateful data in your containers. But another anti-pattern I want to highlight is I sometimes have customers ask me, well, how can I make a backup of my running container? And you're going to find a lot of friction on that. I mean, there's ways to hack around and do that, but the point of a container is it's supposed to be immutable, which means you don't make changes to the running containers itself, and you don't create other containers from backups of those running containers. When you need to make a change to a container and you want to preserve it, you should make the change in the container image, and then upload that new container image and create new containers from that. So that's one I definitely run into from time to time.
Excellent. Another good one, especially for people who are running in compliance environments, Sarbanes-Oxley, PCI, HIPAA, all that good stuff. Storing credentials directly in your image is going to get you a talking to from your security officer very quickly.
Yeah, I bet.
The one thing that containers let you do easily, not necessarily containers, but your most modern web application frameworks make it very easy for you to insert data through environment variables. So cram your authentication credentials into environment variables and feed them to your application that way, instead of having a blessed file that lives in your repo and gets cloned out to all your developers, because that gets real fun when somebody leaves the company.
It does indeed, and I sadly have some experience with that. Having worked on a lot of community software package sharing sites, including Supermarket, Habitat Builder, you can say Docker Container Hub is similar. It's very common for people to accidentally upload their credentials. And often what happens is they reach out to me saying, oh, I did that by accident. Can you remove that from the public sharing site? The problem is once it's up there, it's probably been downloaded by a whole bunch of mirrors. And at that point, what I usually tell them is, I'm sorry, I can remove it, but you need to invalidate those security credentials. I can't guarantee that someone hasn't already downloaded them because it's been on the public internet. Exactly.
And there are schmuckheads who have nothing better to do than write bots.
I don't know if that's better, but it's hilarious.
Anyway, people with less than honorable intentions will sit there and write software that all it does is spider GitHub, GitLab, Bitbucket, may it rest in pieces, all these other public repository sites for any string that looks like it could potentially be a credential. And they take your credentials, and on your dime, they spin up as many BitTorrent mining VMs as they possibly can. And your CFO is going to have a mild heart attack when he or she sees the bill that month. Don't ask me how I know.
I know how you know.
And the good thing is there are options out there that'll for like CI/CD that will detect some of that stuff, at least in environments that you're doing that. Obviously, if they're uploading to supermarket or whatever, I have no idea what's available to that in that sense, but definitely there's lots of things out there to prevent that and look for that in your kind of push back to Git and such.
Right. But that's generally put in place after the first time somebody commits it. And hopefully people at the beginning of their containerization journey will hear this and go, I'm going to learn from their fail.
Yes, this pain-driven development is what I call it.
There you go. I like that. That's great.
All righty. Well, we talked a bit about containers themselves, and we've touched on Kubernetes, but I think it'd be good to talk a little bit about some various container orchestrators. I mean, Kubernetes is the most, I don't want to say notorious, it's the most well-known one. That's the word I'm looking for.
Mm-hmm.
I know Docker Swarm was a thing for a while. I'm not sure how widely used it is now.
Yeah, definitely still there for sure.
Yeah. Ditto with Mesos, CoreOS.
Right. I always want to call CoreOS funding. Oh, I always want to call CoreOS Choreos.
Nell and Scott, let's have a quick chat about why would somebody need an orchestrator in the first place?
Yeah.
I would say they would need it when they're dealing with more than 3 container images. I think at that, or 3 different container images, I think at that point you need some sort of, there's only so much you can do with Docker Compose. I think at that point you need some sort of orchestrator. Also, if you need to automatically mount storage volumes to it, if you need to attach domain names, IP addresses, that's when it's useful to bring in an orchestrator.
All right. So it sounds like when you're just using Docker and you've got your shiny production Docker box and you do Docker run my shiny container image, you can send traffic to that one Docker box. Mm-hmm. But it's that doesn't scale. You can spin up a couple dozen Docker processes until the system resources on that box, whether it's a physical box or a virtual machine, are exhausted. But gosh, it sure would be nice if we could have half a dozen Docker boxes. But
absolutely,
goodness, how can I get my inbound traffic, my ingress, which if somebody is going down the Kubernetes path, they're going to become intimately familiar with that term. Mm-hmm. How do I get my traffic to my half a dozen Docker boxes, and especially given Docker's habit of blinking containers into and out of existence as needed. It's just a normal course of the day.
Right. So I've definitely experienced this, and I think a lot of us have too. Trying to set up networking manually, other than the most basic examples with just Docker containers, is a nightmare. That is one of the big value adds of orchestrators, is abstracting that networking layer away and making it easier to deal with.
Right. So an orchestrator is going to give you the tools to basically describe your end state of, hey, this is what I want running. To a lesser extent, this is where I want it running. If I've got like you mentioned a half a dozen or so different containers as part of my microservices mesh, here is a standardized way for them all to talk to each other. Here is how I'm going to handle not ephemeral data. My goodness, I can't.
Stateful data?
Thank you. Stateful data.
You're welcome.
This is how I want to manage stateful data. And then this is how I want all of my inbound traffic to come in. And then I don't ever want to have to think about it again. Once you've cracked each of those nuts in turn and put them into oh goodness, what's the a Mesos manifest or a Kubernetes?
Kubernetes manifest. I'm actually not sure what Mesos is, but Kubernetes manifest.
Yeah, then it's then you get to forget about it until it's time to upgrade the cluster, ideally.
Right. Nice thing about orchestrators too is when the software is updated or the container images are updated, the orchestrator takes care of rolling out that updated image to, spinning up new containers from that updated image. And when you have different dependencies, that is really, really useful as well. Cool. Well, I think we might be coming toward the end here. Anything else you two want to cover before we move on to picks?
I'm good.
I'm good. Let's talk about picks.
All right. Well, I have 2 picks this week. My first is it's summer. Not that you could tell today in Seattle, but we do occasionally get temperatures up into the 80s and 90s. And people from other parts of the country like to tell me, oh, that's not that hot. How can you possibly manage it? And I remind them that most Seattle apartments and houses do not have air conditioning. So one of the ways to get through it is the last thing I want when it's that hot is a hot beverage, but iced coffee, particularly Trader Joe's iced coffee that comes in bottles or in cans, is fantastic to have in my fridge and just ready to get me going in the morning and cool me off a little bit too. My second pick is a TV show. It is Big Little Lies on HBO, which just started its 2nd season. And I remember when the first season came out, I saw the previews and I said, seems like they're trying to cram every single Oscar winner or Oscar nominee they possibly can into the cast of the show. That could work out great, or that could go really wrong. It did work out great, and season 2, they've added Meryl Streep to the mix. And it's a complex but still human plot line with mysteries to it, and I really enjoy it. So those are my picks. Scott, how about you?
All right, so I've got 2 books that I'll recommend. The first one is fiction. One of the things I'll throw in a tip here is I've been an Audible listener for over 10 years. And I didn't realize that if you go get a library card, a lot of times your local libraries literally will allow you to use, say, the Libby app to download and check out books for free through your local library. Sometimes it takes a while to get the books. So that's actually how I listened to this book, which is fiction. It's kind of like sci-fi. It's called An Absolutely Remarkable Thing by Hank Green. It's fairly interesting. It's not too challenging. You can double speed it. And, but I don't read a whole lot of fiction. And so when I do it, it's, I usually try to save it for really good stuff. So, and I thought it was good. Not amazing. It was definitely not The Martian, which I loved. And the other thing I did, and it's funny, I have a card because I wanted to make sure I hit all the points, but, and so I love a lot of kind of business and science books and cognitive psychology and all kinds of stuff like that. And so there's this book called The Book of Beautiful Questions by Warren Berger. And so for me, I wanted to get better at asking questions, partly because I have to do sales. I think it's also good when you're maybe managing people, when you need to kind of sometimes you can get into conversations with people and they just don't have much to say. And so maybe we just need to be I just want to become a better questioner. And so this is one of the reasons I like this book. And they have a whole question index at the back of the book. So you can literally, if you're struggling with what to say in an email to somebody to try to be more interesting or something, or if you're at a party, I think it's a good place. And so one of the questions from the back is, do I look forward to thinking about this topic? And I've actually had this come up, and it's I've actively made a decision. I've had this thing where maybe I get back, do I get involved with Azure and Microsoft products heavily again, or do I just stay in the open source world? And I've been asking that question of myself for this year. And I basically decided that for the most part, I'm going to try to avoid anything that's not open source. And so just how I kind of use some of this stuff. So that's it for me.
That's awesome. My picks, I've got 3 technical and 2 non-technical ones. Speaking to our containerization Kubernetes stuff, my tech pick this week is for magicsandbox.com. They have some of the best Kubernetes learning resources and labs, which for me are very important. I can read blog posts and how-tos till I'm blue in the face. But for me, until I actually get my grubby little fingers on a keyboard and build something, it tends to be in one ear or out the other, or in one eye and out the other, however that works. MagicSandbox.com is the correct ratio of reading about it and then doing about it in a browser sandbox for me that I found very, very helpful for getting Kubernetes under my fingers. I'm certainly not a Kubernetes master, but I feel like I can talk somewhat intelligently about it, specifically because of their course. So MagicSandbox.com, that's my pick of the week. Nice. My fiction pick of the week, I am a Neil Stephenson fanboy, and his latest book, Fall or Dodge in Hell, which is a sequel to his earlier novel, Reamdy, it is blowing my mind out through the cuffs of my pants, through my socks, and making a mess on the floor. I love this book, and I can barely put it down, and I'm halfway through it. If folks like, in my opinion, well-written science fiction that helps challenge your notion of reality and give you a little bit of, what the hell is going on, kind of, frisson, that's wholehearted recommendation. My last pick of the week, it's more in the podcasting space, but a friend who runs another podcast of mine was asking my recommendation for how can he help eliminate some of the ambient noise in his apartment. And I recommended whisperroom.com, since for a variety of reasons, money is not an object. So he, for a small amount of money, one can get a phone booth or multiple phone booth size rooms built into their, it could be as small as a closet, could be a part of a great room, where everything is just soundproofed. And there can be, jackhammers happening right outside your window, and it's not going to affect your podcast recording at all. So if you need to have the absolute highest quality, ambience for your podcasting, or if you're a musician doing a lot of recording at home, whisperroom.com seems like a somewhat economical solution to the ambient noise problem.
Nice.
Awesome. Well, thank you for joining me in this podcast, Scott and Lee. And thank you, everyone, for listening. And we will see you next time on Adventures in DevOps.
Woohoo!
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit